स्टूडेंट्स, इस वीडियो में हम लोग डिस्कस करेंगे फर्स्ट ऑर्डर रिएक्शन, द रेट इक्वेशन फॉर द फर्स्ट ऑर्डर रिएक्शन, graphical representation of the first order reaction and the half life of the first order reaction along with the general characteristics of first order reactions. फर्स्ट ऑर्डर रिएक्शन जैसे हम लोगों ने पहले पढ़ा है कि ऐसा कोई भी रिएक्शन जिसमें रेट जो है वो इक्वल होता है इनिशियल कॉन्सेंट्रेशन ऑफ द रिएक्टेंट के टू द पावर 1, सो दैट द ऑर्डर ऑफ द रिएक्शन इज 1 ओवरऑल, और यहाँ पे यूनिट के का होता है टाइम इनवर्स 1, दैट इज मिनट इनवर्स 1 और सेकेंड इनवर्स 1 और आर इनवर्स 1. Now let's derive the rate equation for the first order reaction. Suppose equation हमने लिए A gives you products and initial concentration of A is A naught and after time t इसका concentration है A. तो rate of reaction हमने जैसे पहले पढ़ा था कि rate of disappearance of A के terms में अगर हम लिखेंगे तो minus dA upon dt and it is directly proportional to A that you can see from here, and if you remove this sign you will get K, that is rate constant. Now here we can also manipulate it and this equation can be written like this: K dot dt is equal to minus dA upon A. Now on integrating this equation you will get the equation as kt plus I minus log e A, where I is the integration constant. Now if t is 0 means at time 0 A naught is equal to A. Now this putting these equations in equation number 2 here, you will get the value of I as minus log e A naught. Now substituting this value again in equation 2, you will get this equation, and on solving it we will get log e A upon A naught is equal to minus kt, and on further solving you will get the final form of this equation as A is equal to A naught e to the power minus kt. So this reaction shows that first order reaction is an exponential process and concentration of A decreases exponentially with the time. Now here again I am modifying this equation that we have done earlier. K is equal to 1 upon t log e A upon A naught. So here, because the sign is inverse here, you will shift A naught above and A below, so it will become 1 upon t log e A naught upon A, and on further removing this log e to converting log e to log 10, you will get here the term 2.303. So this is another equation which can be used for first order reaction. Now if the initial concentration of the A is A mole per liter and x moles has changed into products during time t is x, so the A will be A minus x, and now substitute these values in equation number 6, you will get this type of equation. So equations 7, 6 and 4 are more or less the same equation and they can be used for first order reactions. Next we come to the graphical representation of the first order reaction. So you can see this from here diagram. You can see this graph is showing you the plotting between rate of reaction, concentration of reactant, and because both are directly proportional to each other, the graph is a straight line, and on finding the slope you will get the value of K here. The second graph is showing you the plotting between concentration of reactant and time t. This shows that with time exponentially the concentration of A is decreasing and confirms the first order rate equation. And in the graph 3, the graph is being plotted between log 10A and time t, and the slope of this reaction will give you the value of minus K 2.303. Next we come to the half-life of the reaction. Half-life is defined as the time taken for half of the reaction to get complete. मतलब कितनी टाइम में रिएक्शन का हाफ रिएक्शन कंप्लीट हो जाएगा, दैट इज द हाफ लाइफ एंड डिनोटेड बाई T1/2. अगर हाफ रिएक्शन कंप्लीट हो रहा है तो A को हम हाफ A नॉट लिख सकते हैं और T को T हाफ लाइफ लिख सकते हैं. तो अगेन द अबव इक्वेशन इज मॉडिफाइड एंड यू विल गेट दिस टाइप ऑफ इक्वेशन. On further solving you will get it 0.693 upon K, and this equation clearly shows that half life of first order reaction does not depend on initial concentration of the reactant. ये सिर्फ rate constant की value पे depend करता है. Amount of reactant left after n half life. Suppose after one half life the amount of reactant will be A naught by 2 power 1. After 2 half lives A naught by 2 to the power 2, that is 2 square, then 2 cube. So above for after n half lives I have derived a general formula that is A naught by 2 to the power n. Though if n half lives are given, you can calculate the amount of the reactant after n half lives, knowing the initial concentration of the reactant. नेक्स्ट इज द कैरेक्टरिस्टिक ऑफ फर्स्ट ऑर्डर रिएक्शन. इस फर्स्ट ऑर्डर रिएक्शन में रेट डायरेक्टली प्रोपोर्शनल होता है इनिशियल कॉन्सेंट्रेशन ऑफ रिएक्टेंट के. रेट कांस्टेंट का यहाँ पे यूनिट टाइम इनवर्स 1 है. फर्स्ट ऑर्डर रेट इक्वेशन ये वाला इक्वेशन ऑब्जे करती है जो हम लोगों ने पहले डिराइव किया है. और प्लॉटिंग अगर लॉकटेन ए और टी के बीच में करेंगे तो स्लोप आपको देगा -k/2.303. हाफ लाइफ इज इक्वल टू 0.693/k एंड इज इंडिपेंडेंट ऑफ इनिशियल कॉन्सेंट्रेशन ऑफ रिएक्टेंट. और अगर किसी फ्रैक्शन इफ यू हैव टू द टाइम टेकन फॉर द कंप्लीटेशन ऑफ द फ्रैक्शन ऑफ एनी फ्रैक्शन ऑफ फर्स्ट ऑर्डर रिएक्शन, देन इफ विल पुट द वैल्यूज हेयर, t is t1/n and the fraction is a/n. Substituting the values, you will get this equation, and in this equation clearly see that there is no concentration term. यहाँ पे कोई भी concentration term involved नहीं है. तो हम ये कह सकते हैं कि अगर आपको टाइम निकालना है completion of nth fraction of first order reaction, तो वो initial concentration of reactant पे depend नहीं करता है. In the next video, we will discuss the questions one from the rate of the reaction that we have dealt in the first and second video, second on the first order rate equation, and third on the half life of the first order reaction.